chapter 3, we are able to use Crunchy to calculate the probability when we have a population, normally distributed population with a certain mean and a standard deviation, with a known mean and known standard deviation. To calculate this probability or proportion, we go to distribution calculator, we choose normal, and then here we can change the values. For example, if I have a population of test score which is normally distributed with a mean of, for example, 75 and a standard deviation of 12, I can calculate the proportion or probability of test score which are less than 85 points, less than or equal to 85 points. We choose calculate and it shows the shaded area on the left side of 85, which means this is the area that contains 79.76% of observations who are less than 85. In our case, we are talking about test score, so almost 80% of test scores are less than or equal to 85. And if I want to see what percent of test scores are greater than 85, I can change the sign here and calculate that. And as you see, the shaded area now moves to the upper side and it shows the right side of 85. And obviously, the probability is smaller and it is just approximately it's around 20%. In previous case on the left side we had almost 80% and on this side we have almost 20%, total of 100% of observations under the normal distribution under the curve. Okay, there is a huge difference between this way of expressing the probability with the one in compared to the one I explained in the class. So in class, we have the x value, and with this x value, we calculate the z value, which is a standardized value of x. And then after that, we say we can calculate the probability of z greater than or z less than or equal to a specific z or standardized value of x. So be careful when you are going to use this, you should enter x here and not the z value. Okay, so this is for chapter 3. For chapter 15 also, be careful, we are calculating the probability for average of observations. So if this one is showing x, in chapter 15, you're going to use x bar, which is the average of observations.